Hi everyone. We are here today and we are going to solve two-step equations and inequalities. So our game plan for today is to talk about inverse operations, and then we're going to talk about solving two-step equations, and then we're going to move into solving and graphing two-step inequalities. A lot of this should hopefully be review for some of you, but for some of you it might be new. So let's first talk about inverse operations. And as you can see by the little symbol in the upper left corner, this slide is in your Unit 3 toolkit that's linked on Schoology. But inverse operations are kind of like opposite operations, or operations that like undo each other. So first of all, the inverse operation of addition is subtraction. In other words, if I take a number, let's say 7, and I add 2 to it, okay, I can get back to that original number by subtracting 2. That gets me back to the original number. So if I add 2 and then I subtract 2, those are inverse operations. So therefore, the inverse operation of subtraction is addition. And similarly, the inverse operation of multiplication is division. So if I start with a number like 10 and I divide by 2, 10 divided by 2 is 5. Well, if I then take that number 5 and multiply by 2, 5 times 2 gets back to 10, to that original number. So again, dividing by 2 and then multiplying by 2 get me back to the same number. So they're inverse operations. So we're going to use that property in order to solve these equations and inequalities today. All right, so things you need to remember when you solve any equation. An equal sign splits an equation into two equal sides. So essentially, you can kind of like draw a line down, at that equal sign. And we call the sides, the 2 plus x would be one side and the 4 would be like on the other side of the equal sign. So when we refer to one side of the equation or the left side or the right side, that's kind of what that means, on different sides of the equal sign. So the goal is always to isolate the variable on one side. And you got to keep in mind that whatever you do to one side of the equation, you must do to the other. So we want to isolate this variable x, right? To get that by itself, on the left-hand side of the equation, we have 2 plus x. So to get rid of that positive 2, we need to subtract 2. And we're going to subtract 2 from both sides. Whatever we do to one side of the equation, we have to do to the other. So 4 minus 2 on the right-hand side is 2. And when we do this on the left-hand side, 2 minus 2, we can think of that as like canceling out, because 2 minus 2 is really 0. So my final answer has to be a variable is equal to a number. X equals 2 is my final answer, right? Okay, so real fast, let's do some practice with one-step equations. So number 1, I'm going to go through some of these with you, and then you're going to do some on your own. But number 1, we have x plus 3 equals 5. So we can think of, the equal sign is kind of like splitting into two sides. On the left-hand side, I have x plus 3. So I want to get rid of that plus 3 because I want to get the x by itself. So the inverse operation of addition is subtraction. So I'm going to subtract 3, but whatever I do to one side of the equation, I also have to do to the other. 3 minus 3 is going to cancel out. And on the left-hand side, I just have x. Because really, 3 minus 3, we say it cancels out, but really it's 0, So if I have x plus 0, I don't need to write that plus 0. On the right-hand side, I have 5 minus 3, which is 2. So my final answer, I have x is equal to 2. I'm going to jump over to number 4. So I have negative 6 plus x is equal to 7. So let me draw my little dashed line. And on the left-hand side, I have negative 6 plus x. So I'm adding the negative 6 and the x, right? But I want to get rid of a negative 6. So to get rid of that, to essentially get that to cancel out, I have to add 6 to both sides. Do you see that? Because now -6 plus 6, that is 0, or that cancels out. And then on the left hand, all I would have left is that x. But again, whatever I do to one side, I have to do to the other. So I'm going to add 6 to the other side as well, and then I have 7 plus 6 is 13. So my final answer is x is 13. Let me jump down to number 5. So number 5, I have 3x is equal to 27. Now 3x means 3 times x. So again, the inverse of multiplication is division. So if I want to get rid of this multiplying by 3, I have to divide by 3. And again, I can think of my like invisible line there. If I divide by 3, 3 over 3, 3 divided by 3 is 1. So really I have like a 1x, but remember we don't really write the coefficient. If we have 1 as a coefficient, we don't typically write it. So I just have an x left. But whatever I do to one side, I have to do to the other. So 27 divided by 3 is 9. So I just get x is equal to 9. Now I'm going to jump down to number 9. Number 9, people see these kind of equations a lot of times and they don't like them. They think, oh my gosh, this is hard. I see a fraction, but don't let that scare you. Remember, a fraction is just another fancy way of writing a division problem. So on the left-hand side, what you have is x divided by 4. That's all that says. It's x divided by 4. So just think back to our inverses. The inverse of division is multiplication. So if I multiply by 4, 4 is really like 4 over 1, right? So really I have like 4 times x, which is 4x, over 1 times 4, which is 4. And then the 4's just cancel out because 4 divided by 4 is 1. So I essentially have like 1x or just x, right? But again, everything I do to the left-hand side or everything I do to one side, I have to do the other. So I'm going to multiply the other side by 4 as well. So I have x is equal to 2 times 4, which is 8. Final answer. Let's do one more like that together. So let's jump to number 11. So I have x divided by -9 is equal to -5, right? So again, to undo division, I'm going to multiply. And I want to get rid of the negative symbol as well. So I'm going to actually multiply by -9 over 1. So instead of writing like this step out here, we don't have to write that out every time. Instead, you can kind of think of the -9 and the -9 canceling right there. And then we just have like x over 1 or just x, right? So I'm going to multiply over here by -9 as well on the right-hand side. So -5 times -9 is positive 45. Make sense? All right, so you guys have a couple more problems to do here that we didn't do together. I want you to pause the video, try these problems in your notes, and then when you unpause, I'll give you the answers and you can check them. All right, welcome back, guys. So hopefully you went through these problems. Here are these answers. So take a minute. I want you to check. Now, one thing I want to point out, especially for problem number 3. For problem number 3, you may have written your answer as -12 is equal to x because you might have subtracted 3 from here. And so on the left-hand side, you got -12, and on the right-hand side, you got x. That is totally fine. X is equal to -12, and -12 equals x. They mean the same thing. So either of these answers are perfectly acceptable. And that's really true for any of these problems. You know, an equation sign means that two things are equal. It doesn't matter which one I have on the left or right. They're equal, right? All right, so let's move on. Now we're going to talk about two-step equations, okay? So really similar. We're going to start by splitting the equation in half by drawing a line at the equal sign, right? So now, just like before, I have like a left-hand side and then a right-hand side. But now I have like a 10 on the left-hand side, and I have this whole part on the right-hand side, right? 2x minus 2. So I have more stuff, kind of. I'm going to isolate the variable. So again, the goal is to get that x by itself, that variable by itself. And I'm going to do that by doing PEMDAS in reverse. And a lot of times I call this SADMEP. So PEMDAS, P-E-M-D-A-S, backwards is S-A-D-M-E-P, okay? So when we do PEMDAS backwards, we're subtracting or adding first, and then we're multiplying and dividing, right? You can see in purple we're going to multiply and divide, but first we're going to add or subtract, okay? So we're going to add the 2, because in the original problem, I have 2 times x minus 2. So I'm going to get rid of that minus 2 first. But again, I'm going to use inverse operations. So I want to get rid of the minus 2. I need to add 2 to both sides. Whatever I do to one side, I do to the other, right? So negative 2 plus 2 on the right-hand side, they're going to cancel out. They give me 0. But on the left-hand side, 10 plus 2 is 12, right? So now I have 12 is equal to 2x. And then in purple, I'm going to multiply or divide the coefficient in front of the variable to get that x by itself. So essentially at this point here, I have a one-step equation, kind of like what we just did. So I have 2 times x. I want to get rid of the 2. The opposite or the inverse operation of multiplication is division. So I'm going to divide both sides by 2. And then 12 divided by 2 is 6. So again, my answer has to be in the correct form. It has to be, a variable is equal to a number. And like we said a couple minutes ago, it doesn't matter if the variable is on the left or it doesn't matter if it's on the right. Either way, it's the same. All right, so we're going to do a couple practice problems together, and then you're going to try some on your own, okay? So number 13. Let me draw this line down the center. And again, I'm going to write this up at the top. We're going to use PEMDAS backwards, right? So we're going to do our subtractions or additions first, and then we're going to do our divisions or our multiplications, okay? All right, so number 13, 2x plus 1 is equal to 7. So when I look at this, I notice that I have 2 times x and then plus 1, right? So again, we want to get rid of our additions or subtractions first. We're going to get rid of that plus 1 first. But we need to use inverse operations. So we're going to subtract 1 from both sides, because 1 minus 1 is 0. It cancels out. So over here on the left-hand side, I just have 2x left. On the right-hand side, I have 7 minus 1, which is 6. Now, again, here, I'm down to like a one-step equation, like I was saying before, right? So now I'm going to use my multiplication or division to get rid of this 2. So this is 2 times x. The inverse operation of multiplication is division. I'm going to divide both sides by 2. 2 divided by 2 is 1, or that cancels out, and I just have x. And then 6 divided by 2 is 3. Let's try 14. Draw my line down the center. So again, I have negative b. Well, let's think about what negative b is. Really, you can think of like, if there's no number or no coefficient in front of a variable, you can think of it as being a 1, right? So this is really kind of like negative 1b here. So I have negative 1b plus 6, right, equals negative 11. So again, I need to get rid of my subtractions or additions first. I need to get rid of that 6. So I'm going to subtract 6 because inverse operations, right? 6 minus 6 is 0. They cancel out. So I just have negative b is equal to negative 17. And I should have reminded you of this already, but you should be using your calculator, all right? You don't have to be able to add quick, negative 11 plus negative 6 quickly in your head. You should use a calculator. So I want to get b by itself. B's not quite by itself, because really in front of the b I have this negative, or negative 1, right? So it's kind of like negative 1 times b. Again, inverse operation, I'm going to divide by negative 1, divide by negative 1. And a negative 1 divided by a negative, negative by a negative is a positive. So now I have b is equal to positive 17. Okay? Let me jump down to number 21. Sorry, let me jump down to number 21. So again, let me draw my imaginary line. Really, it's like the same, more the same, but now my y is just on the right-hand side. So in order to get y by itself, I'm going to use PEMDAS in reverse. And I'm going to get rid of my addition and subtraction first, right? So I'm going to subtract 3 from both sides. And 18 minus 3 is 15 is equal to 5y. This means 5 times y. So the opposite of multiplication is division. So I'm going to divide both sides by 5, divide both sides by 5, and I'm running out of room, sorry about that, but I have 3 is equal to y. So just like before, same thing. It doesn't matter if the variables on the left-hand side or the right-hand side, doesn't matter, it's all the same. Okay? Now I'm going to do one more problem with you. I just want to look really quickly at number 15. So 8x minus 1 is equal to 9. I'm going to get you started on this one. Again, inverse operations. Get rid of the addition or subtraction first. So here I'm subtracting 1. So inverse operation of subtraction is addition. So we're going to start by adding 1 to both sides. So 8x, these will cancel. That's an 8. Equals 9 plus 1, which is 10, right? Now, get rid of the 8. This means 8 times x, so I'm going to divide both sides by 8. What I want you to notice is that'll cancel out on the left-hand side. That's all nice, all fine and good. So I have x is equal to 10 divided by 8. Oh my goodness, that doesn't go in evenly, right? So far, everything went in evenly. And that's okay. Fractions are our friends. You've heard me say that a lot. So we just take this fraction and we reduce it. 10 over 8, what goes into both? I can divide both of these by 2, right? So 10 divided by 2 is 5. 8 divided by 2 is 4. So x is equal to 5 over 4. It's okay to have a fraction as an answer. And one thing that we haven't really talked about yet is when you get a solution, you should be able to plug this value for x or b or y or whatever it is back into the original equation. And it should make the original equation true. So I'm going to go through that real fast with this number 15. I know, annoying that we're going to use a fraction, but that's okay. So 8 times 5 over 4 minus 1 should be equal to 9 if we did everything right, okay? So 8 times 5 over 4, well, this is 8 over 1. When I multiply two fractions, I do 8 times 5, which is 40. 1 times 4, which is 4, right? I'm just rewriting the rest of the equation. 40 over 4 is 10. And 10 minus 1 is 9. And I know that 9 is equal to 9. So check. This was just my check to make sure that I did the problem right. Now, when I plug in x and I, simplify both sides and I see that both sides are equal to each other, this part in blue just confirms that I got the right answer, that this answer here is correct. All right, so you guys have 1, 2, 3, 4, 5 more problems I want you to try. So pause the video, try these problems, and then when you unpause, we'll give you answers. All right, welcome back. So hopefully you had time to try these. Let's check answers. So here you go. Take a minute, check your answers. Keep in mind, doesn't matter what side the variable's on. For example, number 17, you might have gotten 5 is equal to S, and that's okay. All right, so now let's look at what happens if I have fractions. So what happens when I have these two-step equations with fractions, right? Again, like I was saying to you before with the one-step equations, don't let these scare you, okay? We're still going to be doing SADMAP, which is PEMDAS backwards. We're doing our addition and subtraction first, multiplication or division second, right? So let's start with 22. Draw your line down the middle at the equal sign. Here's the x, or the variable that we want to get by itself. So if I look at this, again, a fraction is just a fancy way of doing division. So this means x divided by 2, and then I'm adding 3. So according to SADMAP, I want to get rid of the adding 3 part first. I'm going to subtract 3, because 3 minus 3 is 0. They cancel out, right? But whatever I do to one side, I have to do to the other. So I have x over 2 is equal to negative 9 minus 3. Again, use your calculator, which is negative 12. Now, just like before, this x over 2, this fraction, is really division. So x divided by 2, to undo division, I multiply. When I multiply by 2, I'm really multiplying by 2 over 1, right? So remember what we said before, we can kind of just like cancel these. The 2 over 2 cancels, you just have x over 1, which is just x. But when I multiply the left hand side by 2, I have to multiply the right hand side by 2 as well. So I get x is equal to negative 24. Make sense? So let's just do one more together. Number 23, again, draw your line. We want to get rid of our addition or subtraction first, so we're going to add 27 to both sides, because negative 27 plus 27 cancels out and gives me 0. So on the left, I have x over negative 8, and then I have negative 30 plus 27, which is just negative 3. Now, x divided by negative 8, the inverse operation of division is multiplication, so I multiply both sides by negative 8 over 1. Because remember, if it's a negative number that I want to get rid of with multiplication or division, I have to multiply or divide by a negative, because a negative divided by a negative is a positive, so those will cancel out. So multiply over here by negative 8 as well. So we have x is equal to negative times a negative, which is a positive 24. And there you go. Let me just erase this a little so you can see it. Okay, so now you have 4 more problems. Again, pause the video, try these, and then when you come back, we'll check answers. All right, welcome back. Hopefully you did these 4 problems. Here are your answers. And again, we've said this a couple times, but the same thing is true with all of these problems. For example, number 25 and 27 in particular, if you had 32 is equal to m, that's perfectly fine. That's great. If you had negative 10 is equal to k, those things mean the same. And even for 26, you could have had 8 is equal to x. Because remember, it's an equal sign. Both sides are equal. So it doesn't matter, essentially this is like negative 10 equals right here. It's like negative 10 equals negative 10. I could flip the same sides. It doesn't matter, right? They mean the same thing, okay? All right, let's move on. So we're going to kind of shift gears just a little bit, and we're going to talk about inequalities. So hopefully these symbols look familiar to you. And again, this is in your toolkit as well. But some just quick review with the inequality symbols. So this one here means greater than. This one here means less than. And I was always taught, I always remember the one that kind of points in the same direction is like an uppercase L. So it's kind of like an uppercase L, like slanted to its side is like the less than, where the greater than is like open in the opposite direction. And then anytime you have the like solid dash underneath that symbol, that means the or equal to part. So this one here is less than or equal to. This one here is greater than or equal to, right? I also remember learning like the alligator, the open mouth chomps like the bigger number. So for example, if I had like 27 and 10, you might have filled in the symbol. The 27 is bigger than the 10, so the bigger side goes in there, so 27 is greater than 10, right? Okay. So what does this say in words? It says X is less than 7. And X is really a number. So it's kind of like a number is less than 7, right? Now, how do we graph that on a number line? Think about what numbers are less than 7. What numbers would make this true? What values of X would make this true? So a number is less than 7. Well, here's 7 on my number line, right? So the numbers that are less than 7 would be numbers like 6, 5, 4, 3, 2, 1, 0. It would also be like -1, -2, -3, -4, -5. They would also include fractions and decimals, not just those whole numbers. 6.5, -1.5, -3.3275, whatever, right? Square roots, anything. Any number that's to the left of that 7 on the number line. So what we want to do when we graph is we want any solutions. I'm going to write this down, and you should write this in your notes as well. Any solutions should be shaded, okay, or colored in, however you want to think of it. So we're going to start at the number 7, and we're going to shade every number below it. But really, it doesn't just stop at -10. It goes on forever and ever. So we draw like a little arrow. But where does it stop? It stops at the number 7, but does it include the number 7? It says a number is less than 7, or X is less than 7, right? Is 7 less than 7? No, 7's not less than 7. 7 would not, if I plugged in 7 here, this would not be true, right? This would be what we call false. So we don't want that 7 to be shaded in. So what we do is we use what's called an open circle. So that kind of tells us that we start at the number 7, but we don't actually include the 7. We include like 6.9999999. 6.9999999 is less than 7. It would make that inequality true. So that's shaded according to my picture. All right. Now, what if we had said X is less than or equal to 7? How would that change things? So let me do this in a different color. It would still be all these numbers to the left of 7. So we would still shade this down here and go on forever and ever. But if it's X is less than or equal to 7, 7 now is less than or equal to 7. So 7 would be included. So we would take this point and we would shade it. So this graph now is the blue one, is X is less than or equal to 7. So I think that you probably have seen graphing these inequalities before, but essentially, if you have a less than or a greater than, and you have to graph, the point gets an open circle. If you have a less than or equal to or a greater than or equal to, we would include that value in the solution. So the solution or that value should be shaded, kind of like what we said over here on the right. So we would get what we call a closed circle. Okay? The other thing that I want to point out to you, like a little trick that sometimes we learn, is that you shade the direction the arrow's pointing. So in other words, in this case, x is less than 7, or since we kind of have this blue graph, let me go down here. X is less than or equal to 7. This less than or equal to symbol kind of points to the left, so it's shaded to the left. Does that make sense? Let me change this. And let's say in green, let me cross all this stuff out, okay? And what if I asked you to graph something like this? X is greater than or equal to -2. So x is greater than or equal to -2. Here's -2. If I were to plug in -2, -2 is greater than or equal to -2. According to this over here, it should have a closed circle because it is part of this solution. And x is greater than would be the numbers that are bigger than that, would be these numbers to the right, going on forever and ever, right? So again, that rule kind of holds. This inequality was pointing, you know what I mean? Like, think of this as an arrow, it's pointing to the right side. The problem is, let me show you now this. What if you have something like this? 5 is less than x. So now I made it so that my variable is on the other side. It's on the right-hand side. So we're going to start at 5, and 5 would get an open circle because it's just a less than, not a less than or equal to. And let's think about what numbers would make this inequality true, okay? So for example, let me plug in like, it looks like the arrow is pointing to the left, right? So let me plug in a number like 4. Is 5 less than 4? Think about that. Is 5 less than 4? No, right? So 4 shouldn't be shaded. Let's think about like 0. Is 5 less than 0? No, right? So 0 shouldn't be shaded. So let's think about numbers on the other side. Let's pick like 6. Is 5 less than 6? Yep. So 6 should be shaded. Is 5 less than 10? Yep. So 10 should be shaded. These numbers are over here. So this one would go like that. So essentially, my point in showing you this is because I know some of you guys learned that kind of trick, that you shade whichever way the arrow is pointing. But I want to caution you that you can only do that when the variable is on the left-hand side. And the reason is because we read math kind of like the way that we read words in English class, from left to right. So the variable's on the right-hand side, that kind of messes things up. But what you can do, if you like that trick, if you want to use that trick of shading the way that the arrow is pointing, if you have a solution or an inequality where the variable's on the right-hand side, you can flip it, kind of like what we just did with our equations. You know, our variable can be on the right, it can be on the left. So you can put the variable on the left and the number on the right, but if you flip where that, you know, the two sides of the inequality, you also have to flip the inequality symbol itself. So it was a less than, it has to turn into a greater than. So 5 is less than x is the same thing as x is greater than 5. And now that this variable, this thing that I, just boxed in orange, now that the variable is on the left-hand side, I can use that trick of shading the way that the inequality points. So the inequality is pointing to the right, I can shade to the right. All right, hopefully that made sense. So now let's go on to solving inequalities. So when we solve inequalities, it's very similar to solving equations with just a couple extra things. We're going to, step 1, use inverse operations to isolate the variable. But here's the important part. If you multiply or divide by a negative number, you must flip the inequality symbol. So if you divide by -5, and if it was like a less than, you flip it and it becomes a greater than. If it was a greater than or equal to, you flip it and it becomes a less than or equal to. And we'll go through some examples in a second. The other thing that you need to remember, step 3, is you always have to graph. So anytime you have an inequality that you're solving, part of it's the solution, but then you also have to take it one step further. Always, always, always you have to graph. And again, this slide is in your toolkit, your Unit 3 toolkit. All right, let's jump into some examples. Okay, so solve and graph each inequality. So again, we want the variable by itself, okay? And for the ease of graphing, I'm gonna always try and get my variable on the left-hand side. So number 1, x is greater than or equal to -1. That's done for me, essentially. It's already solved for x. X is by itself. Now I just have to graph. So when I graph, I don't have to make a number line like you saw before that goes from like -10 to 10 every time. What I like to do is I put the number in the middle and then I go like 1 to the left and 1 to the right. So -1 to the right of that is 0, to the left of that is -2. So think of this as like a little portion of my number line, okay? And when I graph, x is greater than or equal to -1. So -1 would be a solution to this inequality. So this gets a shaded circle. And again, remember, anything that's a solution is shaded. So x is greater than or equal to -1. The numbers that are greater than or equal to -1 are the numbers to the right. So we would shade to the right and put an arrow. And again, because that variable is on the left-hand side, I can think of the arrow pointing in the direction of the inequality symbol, okay? So that's my graph. Let's try number 2. So solve and graph. So first, we want to get x by itself. So I have -2 times x. To undo multiplication, I'm going to divide. So I'm going to divide both sides by -2. And if you want, you can draw that little dashed line down the center still, right? So -2 divided by -2 cancels out and gives me 1 or just x. Now, remember my big rule. Let me go back a second. If you multiply or divide with a negative number, you have to flip the inequality, right? Very important. You have to remember that. And that's what we're doing here. We're dividing both sides by -2. So this inequality symbol is going to flip to a greater than. So 10 divided by -2 is -5. Now my x is by itself. So algebraically, I'm done solving. Now I have to graph. So I'm going to graph up here. Here's my little portion of my number line. I start at -5 and going like 1 point to the left and 1 to the right, -6, -4. And so -5 gets an open circle because it's just a greater than, not a greater than or equal to. So that point -5 is not a part of the solution. And x is greater than -5 shades over to the right. So there's my graph. All right. Number 3, so we want to get x by itself. We have 3 times x. We're going to divide both sides. We're going to divide both sides by 3. 3 divided by 3 is 1. So we just have x. I did divide, but I divided by a positive number, so nothing gets flipped in terms of the inequality symbol. But then I have 12 divided by 3, which is 4. So I have 4 is greater than or equal to x. But now remember, if I want to use kind of that trick with like shading in the direction of the arrow, I can't leave my answer like this. I have to flip the x and the 4. But when I do that, when I flip sides, I have to, I have to flip the inequality as well. So this becomes x is less than or equal to 4. So on my number line, I have 3, 4, and 5. 4 is shaded in because it's less than or equal to, and x is less than that would shade over to the left. All right, number 4. So I want to get x by itself. I have x plus 6. The inverse operation of addition is subtracting. I'm going to subtract 6. 6 minus 6 cancels out, gives me 0. 8 minus 6 is 2. So I have 2 is less than x. So again, I can be done here. And if you want to be done here, circle this, right? And graph from here. But if you want to use that trick, you need the x on the left-hand side, and you need to flip the inequality. So I have x is greater than 2. When I graph, I have 1, 2, 3. 2 gets an open circle, and if x is greater than that, we shade to the right. Number 5, we're dividing by -3 because we have -3 times x, right? Divide by -3 because we're dividing by a negative number. We have to flip the inequality. So -3 divided by -3 cancels out, and I just have x. I'm going to flip the inequality, so that becomes is less than. 9 divided by -3 is -3. Graphing. -3 goes in the middle. Fill in a point to the left and to the right. So -3 gets an open circle because this is just less than, not less than or equal to, and x is less than shades to the left. One thing I want to point out real fast, I'm going to actually go back to number 4. Number 4, I dealt with a negative number. I subtracted 6 from both sides, right? But I don't flip that inequality symbol here because I only flip if I multiply or divide by a negative number, right? So even though I subtracted 6 from both sides and 6 is negative, I didn't flip because I didn't multiply and I didn't divide. I did then flip in this step here because I switched the sides of the inequality, okay? But that's something different. So let's look at number 6. So draw our line down the center. So now this is a 2-step equation because I have -4 times x, and then I'm adding 3. So I want to get rid of that adding 3. Inverse operations tells me to subtract. So 3 minus 3 cancels out. I have -4x on the left is less than or equal to 6 minus 3 is 3. Again, I don't flip the inequality because I subtracted 3. I didn't divide, I didn't multiply. Now I have -4 times x, so I'm going to divide by -4. And now I am dividing by a negative number. -4 divided by -4 cancels, so I just have x. And because I am dividing by a negative number, I'm flipping the inequality. Oh no, I have a fraction, but that's okay. Fractions are your friends. So I have x is greater than or equal to -3/4 can't be reduced, so you just leave it. Okay, but where do we put that on the number line? Oh my gosh. If you want, you can use your calculator, type that into your calculator. But -3/4 is kind of like -0.75. And we don't need to be able to find this exactly on the number line. We're not that worried about it. But so I could start with like a 0 and a -1. And then -3/4 will be somewhere in the middle. A little bit closer to -1, but somewhere in the middle. So that gets shaded in because it's greater than or equal to. So it's x is greater than or equal to that, to -3/4, so I shade to the right. All right, so there you have solving and graphing inequalities. Here are a couple you try problems. I want you to try and work through these, pause the video, and then you're going to unpause and we'll check our answers. Okay, welcome back. So some of these might have been a little tricky. For some of these, like number 10, you're going to have to multiply. Number 12, you might have solved. And number 9, you might have solved and the x was on the right-hand side. So you might want to flip to make graphing a little bit easier. But either way, here's your solutions. And actually, I think I just caught a mistake. I think this should be x is less than 0, right? Because we subtract 10, they cancel, and we have, and by the way, don't be afraid of zeros, but we have 0 is greater than negative 5x, divide both sides by negative 5. Oh no, I think I was right. I'm doubting myself. So we have 0 is greater than, I divide by a negative, so I'm going to flip it. 0 is less than x, right? And then, so I flipped that. And then if I want to flip and put the x on the left-hand side, it would flip back. So I was right to begin with. I need to not doubt myself. I'm sorry, guys. Let me get rid of all this. That was right to begin with. All right, guys, so check those answers. Okay, so that's all I have for you. That was a lot in one lesson. So please make sure you can go back and rewatch this at any time that you need help. It'll be posted in Schoology, and check in Schoology to make sure that you've completed all of the assignments that your teacher has given to you. Thanks for listening today, guys. Have a great day.